Composite functions are, just as the name suggests, it's a way for us to look at two different functions, or for a way for us to combine two different functions into one. So first off, just for our notes, let's get a couple of identities down. And we can use them later on. These ones are good mainly just for note purposes. So I've got f plus g of x equals f of x plus g of x, and that's just if I'm adding two functions together. F times g of x equals f of x times g of x. F minus g of x equals f of x minus g of x. A little more space. And last but not least, f over g of x equals f of x over g of x. Have these handy in your notes because they're going to help you out quite a bit on the homework. Let's take a look at how we could possibly use some of these identities with a quick example. Okay, so let's say f of x equals 3x plus 2. Let's say g of x equals negative 2x minus 4. And our instructions say find f plus g of x. Well, no problemo, because we know from our notes that we just took that f plus g of x equals f of x plus g of x. All right, well, that's pretty easy. So that means f of x, which equals 3x plus 2, I can add that to g of x, which equals negative 2x minus 4. All right, well, because it doesn't matter what order I add things in, I can go ahead and flip these things around. Looks like I've got two x's that I can bring together, and a couple numbers that I can bring together. So let's rewrite this so that it's a little bit easier to deal with. So I've got 3x minus 2x, or again, that's just everything underlined in red, plus 2 minus 4. Now, looks like I'm just dealing with like terms. So, if I have 3 x's and I take away 2 x's, I'm left with just 1 x. And then 2 minus 4, that's just negative 2. So I can use these identities to make things that are fairly complicated or might seem complicated not too bad. And it's a way for us to combine different functions. Okay, so that's some identities. Now let's take a look at specific composition, or really what a composite function is. Okay, so a composite function can be written one of two ways. F, and then it's like, it looks like an O, but it's not like fog. It's um, F of G, or you can also write it as F of G of X. Personally, I like to write it this way because it really gets a little bit more to the essence of what we're doing. And that is this. You're going to want to solve the inside, which in this case, if you're looking up at this example, would be G of X first, then use that to find the outside, which in this case would be F of X. So let's take a quick example. How about we use the same ones that we did before? F of X equals 3x plus 2. And G of X equals negative 2x minus 4, with the instructions that say find F of G of 2. Well, all right, I think we can handle this. Remember, we start in the middle first, on the inside. So step 1, is going to be find G of 2. So we look up here, we know that G of 2 equals negative 2 times 2 minus 4. Again, I just got that from our G of X equation. Negative 2 times 2, oops, let's get back to black. That's negative 4 minus 4. Oops, there we are. All right, and so that is negative 4 minus 4, negative 8. Okay, so now I know that G of 2 equals negative 8. So now I take that and I plug it into the outer one, or F of negative 8. So I know that F of negative 8 equals 3 times negative 8 plus 2. Well, 3 times negative 8. Sorry. Okay. 3 times negative 8, that's negative 24 plus 2. Negative 24 plus 2 is negative 22. So that's going to be our solution then.